Alright, so here we have a position versus time graph. Now, the difference between this one and the ones we looked at before is this one changes the direction of the slope midway through. Okay? Now let's say that this occurs at t equals 5 seconds. Let's just throw that. Happens at t equals 5 seconds. Okay? Maybe I should have had that on there earlier, but that's alright. Now, making my velocity versus time graph. Initially, what direction is the velocity in? Negative. So where should we start? Above the t-axis or below? Below. So we should start down here somewhere. Right? Now, what happens at this point right here, the minimum? It's called the inflection point. What happens there?
Changes dimension.
Okay, our velocity is 0, right? And then after, so at that point our velocity is 0. So on this graph at t equals 5, velocity should be 0. After that, what happens, Katrina? It's positive. So our line, most look like that. Now, if our velocity is going from negative to positive, what can we say about the acceleration? What is it, Reggie? It's positive. The acceleration is positive. Okay, we know, so if we go from a negative to a positive, we have to be adding numbers, right? Not subtracting them? Yeah. Right? And we can also see this line and see it has a positive slope. Right? So my acceleration will be positive. Does that make sense? Okay. Now, one more parabola. Say it looks like this. And let's say that inflection point, that maximum, occurs at the same spot, at t equals 5.
Can we just put it on the screen?
Yep, you can put it on the same graph. All right. It's your notes, you do what you want. Okay. Now notice, this one has a little steeper slope to start. Quicker change. Little steeper slope to start. Take a few and draw your velocity, acceleration versus time graphs.
Dang it.
I got the first part.
I have the second part right. Branch, is your daughter's coming to your thing? Or your daughter's?
They, my daughter's wife should be coming, but they, if it's too cold, they might stay.
It's too cold.
The 6-month-old gets to sit in a little case in her car seat. It's nice.
What is she gonna be?
All right. 2-year-old's gonna be a dragon. The 6-month-old's gonna be a unicorn.
That's so basic.
All right.
You're basic. I'm basic? You're wearing a headband.
They're not even close to the same size.
Okay, you got a 2-year-old.
How's that basic? It's more like.
All right, Kyle. Thank you. Caleb. Thank you. All right. First one, velocity versus time. Where does our velocity start? Positive or negative? Positive. Okay? Starts positive. Right? Then is that velocity increasing or decreasing? Position's increasing, but the velocity is the slope getting steeper or less steep?
It's getting steeper.
Less steep, right?
Okay.
So my velocity is increasing or decreasing?
Decreasing.
Decreasing. So how do I draw decreasing velocity? Okay, slope's going down, right? Now, where does this pass through 0 velocity?
5.
5 seconds. So, okay, and then after 5 seconds, it should be. Now the slope of this line, is it positive or negative on my velocity versus time graph? Negative, right? The slope here is negative. So that means my acceleration is? Negative. Okay. I drew this one a little further away because I think this has a little larger acceleration. Would you guys agree?
Yeah.
The green one's acceleration is a little bit bigger?
I would agree with that.
Are there any questions?
Nah.
Does that make sense?
It does.
Okay. Once again, we're getting at what the change in this graph is, right? What's the change in slope here, or what's the change in position? Over time. Change in position over time. What's that called? Velocity, right?
Yeah.
So my slope here is my line here, right?
Yes.
Right? And since my change in velocity over time is called acceleration, right? My slope here is my line there. Okay? Does that make sense, guys?
Yeah.
Okay. Sticking with this velocity versus time graphs. Here I have two velocity versus time graphs. Okay? Right up here. Now, I want to calculate the acceleration from the velocity versus time graph. Okay? I want to calculate the acceleration from the velocity versus time graph. How can I do that? Yep. Using this velocity versus time graph, how can I calculate the acceleration? Find what? The slope. Why the slope, Caleb? Yeah. Acceleration is what? What is it? Acceleration is change in velocity over
Time.
change in time, right? Velocity is my y, time is my x. So this right here, change in v over change in t, this is really the
Slope.
really the slope of that graph. Yeah. I think I should make like caption cards for you guys sometimes. So that's their slope, right?
Have you ever seen that Saturday Night Live skit where it's like a history teacher? And you have to ask Mr. Thompson.
Okay. So since
Okay.
acceleration is the slope on the v versus t graph, I can rewrite that first equation, delta v over delta t, as v final minus v initial over t final minus t initial. That looks a lot more like a slope equation, doesn't it?
It does.
Okay. Now, can you guys calculate the acceleration of the object whose velocity is shown in this graph?
Yes. Well.
Theoretically, I know you can. Rex, I know you have the ability.
I do not.
So I want you to calculate. Oh, the goes here. Calculate the acceleration. Okay. You guys do that? Calculate. I'm gonna erase that. That's terrible.
Looks like cute.
Yeah, it looks like cucumber. Okay. Calculate the acceleration. You guys can do it.
Oh wow.
Theoretically, potentially.
Which one are we doing it for? The first one or second one?
First one. Just the first one. We'll get to the second one here in a second. So if you guys can't see, this is 0, 0, 8, 8, and 2, 2. Or 2, 2, and 8, 8. Just in case you can't see. Yeah, you're right one over there.
Where?
Over
Well, you
there.
need a calculator for this.
No, that's not that far.
But don't worry about how I'm doing my problem.
It's easy.
Here. You're welcome.
I did.
All right, so what do I do? Acceleration equals v final minus v initial, right? What points did you guys use?
I didn't do it wrong.
Caleb uses 2, 2, and 8, 8. Did anybody use 0, 0, and 2, 2? Rex did. Anybody use 2, 2, and 8, 8? Did anybody use 0, 0, and 8, 8?
No.
No?
Everybody do this.
Does it matter which ones you use in this one?
No.
No, why not?
It's constant.
Okay, the slope is constant. Okay. Since the slope is constant, that means the acceleration is constant, right? So acceleration equals 8 minus 2, or 0, right? Over 8 minus 2. Okay? If you did that, that means you're saying this is T final and V final, and this is T initial and V initial, right? Okay? 8 minus 2 is 6. 6 over 6 is 1 meter per second. Meter per second.
Square.
Squared. Good job. Okay. Now, on that graph, that 1 meter per second squared, is that the average acceleration or the instantaneous?
Average.
Because both.
Both.
No.
Okay?
Because it's
Since this acceleration is constant, the average acceleration equals the instantaneous, right?
Yeah.
That 1 meter per second acceleration is over the whole trip, and at that specific moment, acceleration will be 1 meter per second squared. Okay? This is A instantaneous equals average A because A is constant. Okay? Because A is constant. Does that make sense, guys?
Yeah.
Okay. Now look at the next graph over. Is acceleration constant?
Nope.
No. So if I said calculate the acceleration
Well, acceleration's constant, not velocity.
for VT, this is the velocity versus time graph. Okay, is the acceleration constant?
Oh, yeah. No.
No, the acceleration is the slope, right? Right here, the slope is almost horizontal, right? Right here, the slope is almost vertical. Is the acceleration constant?
So you're supposed to go
No.
for the first one.
Okay. So, if I said calc the acceleration, okay, you guys are going to say when, right? Because here acceleration is not constant. So, we could give you time intervals. We could say from t equals 0 to t equals 6,
But there's only 2 points plotted.
right? Or not 6. 8. We can assume that one as well, Skylar. Oh, goodness. Okay. Can assume that one's 0, 0, right? Could you guys calculate this one?
I could.
Yeah.
Theoretically.
Could you do t equals 2 to t equals 8?
Yep.
Yeah? Could you, what's the other one we could do?
From 2 to 1 to.
What's the other one we could do? From t equals 0 to t equals 2. Now, by calculating these, would you be calculating an average or an instantaneous acceleration?
Instantaneous.
Average. Okay? Each of these calculated would be an average acceleration.
Why would that be?
Okay? Because remember, average is total distance divided by total time. So if I look at the acceleration from 0 to 8, right? If I were to use the slope from 0 to 8, it would not be the slope of this line, right? It would be the slope of that line. Okay? At some points, the acceleration, the slope of this line would be greater than the slope of this one, right? At other points, it would be less. It's an average acceleration.
Indubitably.
Same thing if I go from 0 to 2. It'd be the slope of that line, right? Or if I go from 2 to 8, it'd be the slope of that line, right? Now, which of these lines is closest to the acceleration at this spot right here? The green one, okay? Because as we get our time window, t equals 2, t equals 8, t equals 0 to 8, or t equals 0 to 2, as we make our time window closer and closer and closer to that point, we get closer to the actual acceleration at that specific spot, right? If I wanted to find the actual acceleration at that specific spot, do I have to use one of these lines or should I use a different line? Different line. What should that line be to the graph at that point? Talk about it a little bit. Should be parallel at this point, right? What's the parallel line called at this point? Nope.
Midpoint.
It's called the tangent.
Yeah.
Okay? If I want to know the instantaneous acceleration at this spot right here, then I would need to calculate the slope of that green line. Okay, does that make sense? These are all averages because I have a large time window. Does that make sense, guys? Okay. Now, this is a constant or non-constant acceleration? Constant. This is a non-constant. Okay, we're going to live more in this world in our class. Okay? But this does happen. Okay? It could come up every now and again. Alright, so it's important that we talk about it. Alright? Because constant accelerations don't always happen. Now, physics is substantially easier if we're dealing with constant accelerations. But if you go on to like college level physics, or if you go on to maybe even AP physics here, changing accelerations could come up. So it's important that we know what that graph looks like. Okay. Well, I hope all of you do that. Any questions?
I'll do it.
Any questions?
Do we get honors?
Can I have an answer?
I don't know.
AP, you get a college credit, don't
Off-topic
you?
question?
What?
Can I ask a slightly off-topic, well, really off-topic question?
A really off-topic question.
But it has to do with school.
1, 2, 3, 4, 5, 6. What's that, Amani?
Are we ever gonna get debate back as a class?
I have no idea.
You want debate?
That's not my department.
Who taught that?
I don't know.
You're the only
Okay.
one that won't think about it. You're the only one that won't
Guys.
think about it.
Thank you. I'd like you to draw these two graphs. There's 2 more things I want to cover today, or talk about today, and then we'll be done.
We'll
How long
check
do these two
none
things
better
take?
one.
Not that long.
About an hour.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. This is 1, 2, 3, 4, 5, 6. That's a 6. Notice the graphs are just a little bit different in scale.
I love the big Mexican accent.
For the sake of round numbers, guys, I adjusted my scale here. We'll call that 8. Okay. Thank you. Okay. So here I have 2 velocity versus time graphs.
You sure?
Okay. Right? Thank you, Rex. Appreciate your affirmation. We'll call that time 10. So this is going to be not 6 10. This will be 10 6. And this point right here is going to be 8 10. Okay, does that make sense, guys? Okay. So object 1, object 2. Here's my question. How far did the objects go? Okay. Basically, I'm asking, what is the displacement? Okay. Now, if this was a position versus time graph, it'd be easy. The displacement is the final d value, right?
Sure is.
Right? But is this a displacement versus time graph? No, it's a velocity versus time graph. So the question is, how far did the objects go?
Just fine.
Thank you, Rex. You and your general answers. Okay. All worth 0 points on a test, but they'll make you smile a little bit. Okay. Your test is gonna be really easy to grade.
It's fine.
So, object 1, object 2. Which one do you guys want to look at first? 1. Okay, we'll go numerical order. That's fine. All right. Where is displacement on here?
There is.
Right there.
Right there. Thank you. It is right there, but you know right where though, Jameer?
It's
Right there. You're just pointing generally.
It's positive.
Right
10 and
there
6.
is-
But you know, Jameer pointed at me, so he says I'm the displacement. All right. So where's the displacement?
10 and 6.
What's this quantity up here?
Velocity.
Velocity. What's this quantity down here?
Time. There isn't.
Time. Do I have any equations that have velocity and time in them? And displacement?
No.
This.
Yes.
3,
Or 5.
right? Or 5.
Or 7.
If I look at equation 3, velocity equals delta d over delta t, right?
Sure does.
I want to find displacement. I have velocity and time values, so maybe if I rewrite this in terms of displacement, I can figure it out.
Oh, so you do t times
Yeah, right.
t, then t times v.
Okay, so multiply both sides by delta t, right?
Yep.
Yep.
Right? So I want to end up with this. Delta d equals v delta t.
You know that.
Yes. Okay. Delta d equals v delta t. That's our equation, right?
Uh-huh.
Now, is there anywhere on this graph where I might find the quantity velocity times change in time?
What?
Velocity. Is there anywhere on this graph I might find velocity multiplied by the change in time?
The ordered pair.
Okay, that ordered pair right there?
Yeah.
Well, that's just time comma velocity.
But that shows
That's not multiplied.
from one point to like from zero to
If I go from here to here, How far have we gone on the time axis?
10,
10, right? My time is how many seconds?
10.
10. If I go from here to here, my velocity axis is gone how many units?
6.
6. So it's like I have what shape here?
A square. Rectangle.
A rectangle that's 6 by
10.
10. So where on this picture is 6 by 10 represented?
The whole area in between it.
Good. It's the area. That area right there, that is.
What about the white in between?
Okay, Rex, you know what I mean. Okay.
I wasn't sure.
This area right here is V times delta T, isn't it?
Yeah.
Okay. So if I have a velocity versus time graph, okay, when they're asking for what's the displacement, okay, then what they're asking for is what's called the area under the curve. Okay.
That sounds something shady.
Well, the curve is any line. Okay. Any function is just called a curve. It's a general name.
It sounds
Okay.
like a creepy place.
So here's the curve, right?
Yeah.
It's just a straight line. The area under that curve is my displacement. Okay? So for this first one, our displacements from t equals 0 to t equals 6 for object 1, right, number 1,
6 times 10.
okay? All right, is equal to the blue area. Can you guys figure out the blue area?
It's already up.
Well, we shaded it in, but can you figure out what the number is?
Oh, yeah.
6 times 10, right? So the area
Wouldn't the t have to be 10 centimeters?
equals 6 times 10. Right? What's 6 times 10?
60.
60. Okay?
Grammar.
What's the unit? What's the units?
Meters per second squared.
Nope.
Meters.
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 Okay? Because 6 is a meters per second, right?
Yeah.
The velocity. 10 is a second. Meter per second times second makes
Meters.
Meters.
Seconds cancel themselves out.
just meters.
The
Meters.
seconds cancel themselves out.
So,
Yep, I know.
excuse me. So our change in position is 60 meters. Does that make sense, guys?
Yeah.
Can you find it for object 2?
Theoretically.
Oh my gosh.
Rex, that is your word of the day, isn't it?
Yeah.
Okay.
That's a big word that he knows how to use.
Guys, I have 10 minutes left. Okay? Please find this for me. I know you can do it. What equation might be helpful?
Number 3.
Area of a triangle is what?
Base times height times 0.5.
Okay, 1/2 base times height.
I did that yesterday.
So, for number 2, I want you to find delta D from t equals 0 to t equals 8. Okay? Excuse me.
Wait, for number 1, that wouldn't have to be 10 instead of 6. For t equals.
Oh, yes, thank you. Thank you. Guys, this was a 10 earlier. I don't know why I wrote 6. That was a 10. My fault.
Why?
Because the time axis went to 10 and the v axis went to 6. Need help? Let me know.
I think it's 40.
I think it's 40.
Yeah.
What?
Pretty sure I heard what you said. Pretty sure. But if I heard it correctly, we all good.
All right, sounds like we're done.
Yeah, there's 40.
Okay, so our displacements
I theoretically.
is that area right there, right?
Yeah.
Yep, 40
That's our displacement.
40
So to find that, we need to do 1/2 base times height because it's a triangle. It's a right triangle, right? What's my base?
8,
8. What's my height?
10,
10.
half,
So our area equals 1/2 of
8,
8 times
10,
10. 8 times 10 is 80. Half of 80 is
40.
40. So that means our change in position, or our displacement, was 40 meters. Okay? Now, are these positive or negative displacements? Positive. Where might a negative displacement be?
On the bottom of the axis?
On the bottom. So if we were to use like object 1 from earlier in the lesson, okay? Object 1 from over here, Would this one have a positive or negative displacement?
Negative.
Negative, because its area would be
That area.
right there.
Brent,
Does that make sense, guys?
instead of drawing the line right there, could you draw it going the other direction?
What do you mean going in that direction?
Going from the.
Go like this?
Yeah.
No. Because it has to be the area between the curve and the time axis.
Oh, okay.
Okay? Now, right now, you're probably saying, why does it have to be that way? Because if I have one like our first object 1,
Yeah.
right? If you're drawing the area above the line, now you have an infinitely tall box.
Like,
Okay? All right. Any questions?
Oh, I get it, yeah.
Any questions?
no.